I've got something a little bit different to look at today. Finally managed to find some time to do this, being busy with work. What this is, it's a Sony camera control unit, CCU for Triax. Triax connector. This is it's not in very good shape. It's a CCU-TX7 so it's the PAL version. And what this does is it joins all your equipment in your studio or truck to your camera through one single cable, the Triax cable. So it's like coax, but it's got another shield on it, which is usually a ground, and then the inner shield is the signal return, and then the signal core inside it carries power to the camera, signals and control to the camera, and all the video and sound back from the camera to here. So it powers the camera and bi-directional communication and video and other signals over one cable. So you don't need to have big thick multi-core camera cables anymore, just one nice but not cheap Triax cable. So I've got a couple of these things. This one's in, although there's stuff rattling around, it's in better condition than the other one, so we're going to take the other one apart. This one, the front door doesn't shut. I guess it's been dropped or been mistreated in some way, and this one also doesn't have a rating label anymore, which is why I showed the other one. It's just gone. Yeah, it's definitely been dented, damaged somehow. So inside here there's an optional part on the front that can be removed and a control panel can be put there, or you can use remote control panels with it, and we might have a look at one of those on another video. This thing is quite heavy. So inside here there are a bunch of cards for doing different things, which we'll take a look at. And I think all that part there is power supply. And I think something's happened. That door thing, the bracket for that door is snapped off, and yeah, the hinges are bent. Let's take the top off. We'll start off doing that. Yeah, there's been been trying to make progress with some work, so I didn't have time to make videos because yeah, they needed some stuff done after hours work in addition to normal full-time work. So come off already, just like it. Okay, there's an aluminium top. Okay, that doesn't reveal much. It reveals that it's been dented in the back as well. So this thing's been abused a bit from all angles. Okay, well, let's just continue taking things apart. So I asked, just for fun, since AI seems to be the thing these days, I asked ChatGPT what Triax is and how does the Sony implementation differ from Panasonic, and got some kind of answer, but nothing too convincing. We'll have a look at that in a moment. If you read the Wikipedia page on Triax, it says it uses frequency division multiplexing. So the signals traveling to and from the camera get RF modulated into different frequency bands depending on what signal it is, and then that gets sent probably by that cable there. Oh, there's a dent there as well. Yeah, I think this thing's had a tough life. So the RF signal comes out this coax, and then you choose there whether it comes out of the Triax connector or the coax connector. So just down a little bit under the Triax is a coax connector, so you can use that to connect to your camera and you get all the same features, but it doesn't send power as well. We just have a look at the I/O we got on here. Program audio input, RTS or Clearcom intercom, remote control of waveform monitor mode selection thing, I/O for tally lights and intercoms, 2 serial ports which can link between multiple units, SDI output, the microphone output, where the signal comes from the camera's microphone inputs. Then we've got the video outputs, which is in some composite waveform monitor, a sync output, an unused, and then there's 2 sets of either red, green, blue component or YC S-video, and I think Pix has got a character overlay on it. Then for the inputs there's a Genlock, the sync input, return video 1 and 2, which is like not the teleprompter, that's got its own one. So that's you can send the on-air program back to the camera operator so they can see what's going on, and some other video signal. That's video and teleprompter, so that's 3 sets of video signals that go from here to the camera, and they have 2 connectors, and you can choose whether they terminate on here or they loop out to another thing, because you could put these through all your camera control units so that they all get the same prompter and the same return feed to them. So in that case you put the termination off and terminate it at the last one. Now we can have a look here what GPT 3.5 told me about. I said, describe the technical details of how a Triax video camera interface functions, include differences between Sony and Panasonic implementations. And the reply there was, Triax video camera interfaces are used to transmit video signals from the camera to the video production system or control room. The term Triax refers to the specific type of cabling used. And while the fundamental principles of how Triax interfaces work are similar across different manufacturers, there may be some differences in implementation between Sony and Panasonic. Yeah, I don't know there's not much information about the actual functionality. This is weird bit here. It says Triax cable is a 3-conductor cable with a coaxial cable inside it. That's correct. But then it says, see, it's confused 2 things there, because that is the correct description of the Triax, that it's a coaxial cable with an additional shield. But then it says the 3 conductors carry video signals, component video signals, which is not correct because it's only 1 signal conductor. So don't believe everything that ChatGPT tells you. The camera control unit is also used to control the camera's settings remotely. Yes, so through the control panel you put on here or through external remote controls. And then the differences are quite, it just says Sony has a long history of manufacturing. Sony cameras have unique image processing technologies. Panasonic is another prominent manufacturer. Their cameras may offer different features, and that's it. I asked, describe how analog and digital Triax interfaces within the context of studio video cameras. That's a bad question, isn't it? I think I missed a word out. Anyway, it's got some... I think I wanted to say, describe how analog and digital Triax interfaces differ. Yeah, I messed that one up. Anyway, it gave some answers there. Triax is reaching end of life because the bandwidth available on that single conductor is not infinite, and now people want to do 4K and all that business. An alternative has come up, which I've got a little bit of here, and this is what's replacing Triax. It's, well, from one manufacturer I guess, it's a similar sized connector, but it's got 2 fiber optic cables within it, these 2 here, which come out to those ends, and then it's got 4 electrical conductors, which 2 are just some kind of signal and the other 2 are power and ground. So that's, I don't know what you call that, but yeah, this arrived amongst all sorts of other random junk that I got. Yeah, so that's what they use now instead of Triax cable. Alright, let's get this thing apart. I also got some CCUs, Panasonic ones. So depending on how this goes, whether it takes a long time to get this thing apart, we can take a look at the Panasonic one as well. I don't have any Sony cameras that support Triax. Did not receive any of that in the junk. But what I have got is the Panasonic camera end of a Triax cable. And now we've done it. I suppose we could do it the proper way, which is to slide the boards out. I think it might not slide out very easily because of the way the housing is bent there. And you see that locking thing is snapped off. It's a little hinge thing which can keep the door from shutting automatically, shutting by itself. So there's a little thing down the bottom there which stops the cards from accidentally coming out. So that has to be removed. A retainer. Now there is a service manual for this device which I found, so we can have a look at that to see the function of the various boards. SDI output is an optional feature, and you need to have an extra board fitted to support that feature, and these do have it. These cables here on the front, 2 coax cables, they send the SDI signal comes off the front here and goes to the back panel through these 2 wires. So in order to get that board out, we need to unplug those. I guess that's because they can't get the high bandwidth of the SDI signal through this back plane. So that's the board that presumably turns the analog video component video signal into an SDI signal. I wonder if that could be used as a converter, maybe. Next board we got a bunch of stuff. We'll take a look at these a little bit closer in a moment. It's got surface mount electrolytics. I wonder if those are all ready to give up. Lots of very RF stuff here. Genuine bodge. It's up on little standoffs and then wired in. Now does this power supply come out? Not sure what's holding that in. Probably got leaking caps in it because it's a switching power supply and they're good at doing that. Maybe there's screws on the bottom for this. Yes, there are screws on the bottom. Okay, so that's starting to move, but I'm wondering, surely we've got to undo a bunch of wires to get the power supply out. We'll take the back off. I want to have a close look at this Triax connector and how it's powered, because it's generally 100 volts or so. I think it's written on, yeah, the Panasonic one says that it's 100 volts on the Triax connector, so you got to be careful with that. Presumably Sony's one will be a similar voltage. Nice high voltage so the current can be low, since the conductor is not very thick. Ah, look at that. So that's been bashed in quite hard. Just bent the back panel and pushed this into that box. Oh, it's also cut through a cable. Oh no, it's cut through the coax cable. This nice little coax which goes up to the connector has been chopped through by that metal bashing into that metal. That's unfortunate. I thought that middle box thing there was going to be a power supply thing for driving the connector, but it's not. It's an RF thing. And that coax comes straight out of it. Yes, that's ruined. That's unfortunate. Yeah, so I don't think this would have worked. If it does work, it doesn't work because it's been bashed. If it did work, it doesn't now. I don't know if that happened in shipping it here or that had happened prior to me receiving it. Who knows? This just came in a shipment of stuff where someone said, "Do you want all this stuff?" And I said yes, and they sent it, which involved a bunch of these and various other bits and pieces and unrelated cameras and things which we had previously been taking apart. Okay, so that's the back plane. Oh, and this RF module thing is screwed onto it, so it's not actually soldered down. Interesting. Just get some of these power supply wires undone. The power supply wire coming from the Triax connector. Accidentally ripped a pin out of that. Okay, so this is freed now. So you can see that's bent quite a bit. That's been bashed in. So is that. And yeah, in doing that, it's chopped through that little coax wire, which is the main signal going to the Triax connector. Unfortunate. So that comes from, I guess that's a multiplexer. It says MPX on it. I guess we've got to get that open and see what's inside it. But yeah, it's got these nice little connectors joining all the different signals to it. Find some kind of screwdriver to get it open. What is in this thing? It has been soldered down, soldered shut in the corners. Yeah, that's cracked off because of the way it's been bashed in one of the corners, but not the others. I'll work on this. Alright, inside that metal box, it's a bunch of filters. I guess that's a RF combiner and decombiner. See, there's a whole bunch of capacitors there, and on the other side it's got variable inductor coil thingies. The wires are soldered into this in quite a budget way, not particularly well dressed, those wires. It's interesting. And there you can see the main one there is damaged. Okay, so it's not an active device. I was wondering, there's no power supply looking signals going into it, it's just RF signals. Passive combiner, decombiner. We'll take a look at the Triax connector. This will have a filter on the power connections. I think that's what this is. So that the RF doesn't go into the power part. That's a little bit different to expect. There's no, the coax disappears and it's just thick wire, single strand wire. Let's see if we can get that off, since it's all bent out of shape. It's bent over. I can't easily get to it. That is unfortunate. The screw thread is so squished there. It's and it's bent that the screw head is not accessible. The thread is stripped out so it won't engage. Let's try something else, because that does not come out because the threads have been stripped off of either the screw or the hole, so it does not come out. Probably need to saw it out or drill it out. Alright, can't get those out either because they're bent inwards. The screwdriver can't line up. If this flare part could come off, then we might have a chance. Anyway, we'll just have to look at it as is. So we've got the center signal conductor and then the inner shield there, and they're connected to these two wires, the brown one and the white one to this little board, and that black one goes to the screen, the outer screen. Now this here goes to the coax connector for coax only, not Triax. And then it's just connected through with those straight to whichever one you plug it into. It connects straight through to this, or if you plug into this one, then it goes through a little tiny inductor, then through this capacitor that will be blocking the voltage, the DC, and then it goes, I think, onto that one, terminal 1, which is the brown one, so that must be the center, and then the power must come in onto that, through that inductor. Okay, very good. That's what the Triax connection looks like at the base station or CCU end. A lot of connectors. Now I want to get this power supply out and have a look inside it, see what its deal is. See whether it's got any issues. So the rest of this is just a frame and this control panel part. Oh yeah, that's right, you peel that off and then that gives you the connector where you connect the additional control panel onto. Oh, you have to take that cable out. And that one. It's just some controls. Alright, so I think we're done with that frame part. Now take a look inside this power supply. Looks like it's got a board on both sides. It's pretty heavy duty. What comes out? Okay, we're going to have to take the fan off, and then there's screws underneath it. This thing's probably noisy. Got a lot of professional video equipment's really noisy. Fans and everything, because it's so tightly packed in. Convection cooling is not good enough. Now there's 2 more things to undo here. 3, there's one here. 4 is probably that one. 5, that one. Everything's all dusty and rusty. And because the fans can cause low pressure air, which then causes condensation. And then things rust and corrode. Especially right around the blades. Like cavitation. Okay, see, you can power this thing from 12 volts using the standard 4-pin XLR or from an AC input. So this must have an interesting converter in it if it can run from either of those voltages. Just some sort of step down and a step down converter, then a DC to DC converter which handles creating all of the different output voltages, I would assume. That board's been mounted as well. It's just a shield. Okay, well, it's been pushed in there. Interesting, it's got wires going onto it. Different shields for different areas, and each one's got a QC tab, like with a wire joining onto it. Interesting, very thin PCB material. Okay, we can see some different areas of the circuit. I guess this is the main output part because it looks like all these wires that come off of it are coming off of that one connector there. Although the ones from this thing, Triax, go somewhere else. Pretty sure we have to take it off to have a look where. So it seems to be that separate section there. Transformer, then this section here has a transformer as well. It says here primary, secondary. Maybe that's, I don't know if it's the high voltage part, or is this the 12 volt input part and they call that primary. So presumably they want to isolate the 12 volts as well from the main rest of the system. Well, it has to be converted into many other voltages regardless for running the various analogs and digital things. Are there board-to-board connectors in this? There's a lot of stuff in this. Why won't that lift up? Probably have to undo all those wires. Okay, there's a little circuit breaker there on the bottom, just there. So I guess that makes a little button pop out the bottom of the unit if it trips. Circuit breaker, 10 amps. Wow. Oh, that's on the 12 volt input. 12 volt input goes up to 10 amps. Did we see what the AC input rating was on that thing? Guess it'll be a fair bit if you're powering like big studio cameras with it, with CRT viewfinders and things. Ah, look, you have to undo this. Some devices clamped onto that as the heatsink. Ah, okay, so the Triax wires, those three, go onto the other board. So it's not all in one across this thing. Get some cable ties off. Oh, there's another thing that goes between the boards. And another thing here. Oh, okay, there's not much on the back side. It's all on this side. Look at all those wires that came with it. So many wires going between the bits. Really nice soft wires. Ah, so the main output connector there with the three wires, I guess it's got some protection relays. So that comes from here and to there, protection relays filtering then these outputs. So that comes off that, off those terminals there, those capacitors, that supply there, which I think is at those windings. Yeah, it looks like it. Okay, and then other windings of that go and do the other outputs. So what is that then? Not sure. I wonder if that's the mains input part through that one, and then the 12 volt input joins in another way. Looks like it. Then you see this here, it's got that circuit breaker. Could just look at the schematics, couldn't we? That's not so fun. We'll work it out. Okay, so 12 volt input here goes down onto this. It's got some filters. Then, so maybe that's a crowbar. It says CR5, probably an SCR crowbar in case you join it up around the wrong way. Presumably. Then there's a bus bar down to there. And it looks like there's one on the other side as well, because you see there's two pads. So presumably there'll be one on the other side. Is there a lot of stuff on the other side? Look at all those tracks. And then the wires there will carry that 12 volts up to this side here. So I think that's the 12 volt input goes straight into this converter, and the 230 volt, or yeah, the wide range, the AC input. Then the AC input comes in here through those wires onto this part, rectifiers switching onto this one. So it is kind of two switch modes in one. Quite exciting. Lots of stuff doing this. Just get this board out so we can see what's on the other side of it. So I guess the power switch switches the AC and the DC by the look of it, and a signal, because you see the, is that true? No, I think it's just, no, it's a 2-pole switch. The AC comes in from this end down here, filters down on this side. You see it's designated as an isolated section with that line there, secondary, primary. So that's a double pole switch for the AC, and then it's a little signal switch which presumably turns on the DC to DC converter when it's powered by DC. Is this ready to come out yet? Nope. Still more things. What's on the other side? Wow, there's heaps of stuff on the other side. Look at all that. All the switch mode controlly, sensing, feedback, fault protection stuff. Looks like the flux residue hasn't done it any favors. Okay, so that's all the switch mode controllers. So this part here is just mainly the power part. Interesting then that there's 250 volt caps on the secondary. I think they might just directly go out to the camera. Maybe if there's quite a high voltage one on the quite a high voltage on the Triax. Okay, well there's power supply. We'll take a look at these boards. Think about what they do. Before we have a look at the signal boards, here's the schematic of the power supply, although it's split across 3 pages in a bit difficult to follow away. But here's the AC input up top left through the power switch, and then the 12 volt or 10 to 17 volt input circuit breaker goes through there to the other board. Well, there's the DC output. It says it's 120 volts. Guess it's 120 volts. Does that come from here? Yeah, okay, so there's that connection coming through. Then there's some enabling and disabling FETs, relays, 2 poles in series, double protection. There must be a current sensing resistor, maybe that, probably that. It goes into those op amps there, and yeah, through some filters to the output. More of that logic stuff. Now onto the other board. So what have we got here? Is that the AC input? Looks like it. There's a rectifier. So AC input, and then it's just a standard switch mode to there. Some kind of regulator thing. Main current path through here, and then that goes to a secondary converter, which then produces all the different output voltages. Common inductor thingy there. And then on the other side, we've got this one, which will be the low voltage DC input, and then that switches through this transformer. Okay, so that just makes all the outputs again. So it is actually 2 power supplies in parallel, one with a like 100 to 240 volt AC input, and the other one with a 9 to 17 volt DC input. And there's a CT, so it can measure the current. And it's got some max, though just gate drive chips. Yeah, from the other side where all the control stuff is. Yeah, so it's 2 switch modes in parallel. The transformers produce all the different voltages. And there you go, that's the power supply. Now let's have a look at the signal board. So this one here we've got is really the ES20 board. Does it say that anywhere? Oh, it says it on the front. Okay. Yes, I'm just looking because they come out in this order. So it has to be that one, ES20. So there are descriptions here. ES20 board. This board produces the video baseband and RGB signals from the component signals sent from the YD26 board, which will be the next one we look at. It switches these signals and outputs them as the waveform and pix signals. This board also generates the sync and color bars. So the next one we got is YD26. So this one demodulates the components, the cam, sync, and skin gate. This circuit consists of cable length detection circuit, cable length compensation circuit, and the demodulation of those signals mentioned. The cable length detection detects from the amplitude of the Y modulated wave. In accordance with this, the cable compensation compensates the amplitude of the phase matching as cable length to modulated waves of Y or differential signal. After that, they are respectively demodulated. Okay. Yeah, so depending on the length of the Triax cable you connect, it will need to drive the signal differently. There's some big caps on there. AA90. This board demodulates the RF signal from the microphone's intercom, cam data, and tone from the camera adapter and modulates a program signal, the intercom signal and control data to send to the camera, and handles the... So this one's all about the audio and control signals, modulating and demodulating. Those big caps there, Nichicon. So they look like surface mount caps, but they're leaded. I wonder if there's much on the other side of these boards. I should take this one off the tray to have a look at the back. There's a reasonable amount of stuff on the back. Quite a lot of surface mount parts. Through wave surface mount, you can see the glue blob there. Must be a test pattern to check that the gluing is going right. You can see the glue squidged out from the parts. Some ICs go through the wave as well. Bigger pads on the end to catch the tailing edge of the wave to stop it bridging. Looks like it travels this way because you can see there the blob of solder is much bigger on that end than it is at that end. Only a little bit, but CT181 board. So it's got a big description. It's got the microcontroller on it. So it has it employs an RF system circuit that consists of return video modulation circuit, prompt video modulation, and microcomputer system that controls the system. Okay, so this is for modulating the video signals that get sent to the camera. I think those covers are soldered down, unfortunately. There's a selection here. It says prompt RF TX, prompt RF RX. Does that mean you can plug them together to test it, maybe? Not sure. It tells you what happens there. It says the return video modulation circuit frequency modulates the import composite from return video 1 or 2 and sends it to the camera adapter. Change of return video 1 or 2 is switched by return 1 and 2 changing switch on the camera adapter. The prompt video modulation circuit amplitude modulates the composite from prompt video on the rear panel and sends it to the camera adapter. The prompt video modulation circuit becomes auxiliary video demodulation circuit by switching switch 002 to that and connecting the RF coaxial cable to CN3 to 8. So pulling that off there and putting it onto there and doing that, I guess. So what does that change? It becomes auxiliary video demodulation. Oh, and you have to change another board. YD28 or something. Okay. Did we do AA90? Yeah, we did. Okay, so the final one is the SDI board, SDI44 here. This board converts the analog video audio signals into digital signals and outputs them as SDI. So it says the board, so video processing, so the component signals sent from the ES20 board are converted from analog to digital subject to a double oversampling process in IC308. So that's that one there. Then audio processing, mic 1 and 2 signals are sent from the AA90 board, converted from analog to digital to a 64 times oversampling of IC904. Don't know where that IC is. Oh, so it's that one then. Oh, no, hang on, I'm reading it wrong. It says it's converted by IC904, then subject to time-based compression on 404, which is this. So I don't know where the ADC part is. It's probably something obvious on this, or it's on the other side. The digital video signals and the time-based compressed digital audio signals are mixed on IC413 there. After that, the parallel data is converted to serial data on IC702 and output from this board on those connectors there. Okay, so that's the thing that turns it into serial data. Interesting, that's the analog component video to SDI conversion. Alright, I think we'll finish this one here, and then next time we'll take a look at the Panasonic camera control unit and also the part that goes on the camera and is at the other end of the Triax cable. I've only got the Panasonic versions of that. We'll take that apart and have a look inside it, have some kind of power supply thing in it. But that will be next time, so stay tuned for that. Hopefully looking inside this Sony CCU-TX7 has been interesting.